Okay, so again, what we did is I had you guys go through the whole limit process, but everybody only did 1 point, right? And then I'm having you graph these. So this is now a velocity graph. Okay, now, you guys hold on, stay here. Stay with me, stay with me. This is like our biggest day. We're so important today. We're finding our first exact derivative equations today. It's a good day, okay? But here's what I want you guys to understand. All of math is built on patterns and on the laziness of mathematicians, okay? So we start by adding, right? Ancient Egyptians, right? Okay, ancient Greece, right? They start and they're counting and they're adding. And they realize, man, for me to be able to do calculations, I want to find some patterns to this addition so I could do it faster. Well, what's the main patterns of addition that help us add things faster?
Multiplication.
That's what multiplication is, right? And then we go through and we say, oh, look, there's patterns to multiplication, right? So now I can do bigger calculations much faster. Insert exponents. You with me? So I want you to imagine this process a similar way, okay? We're starting with the most basic building blocks of calculus, which is limits, okay? Then what we do is we realize with limits, we can use those to help us find exact derivatives at specific points, right? But let's say I had a much more complicated situation, right? This is just an easy one for time. But let's say we were doing something with like a rocket ship or something, right? And we needed its velocity on the course. Obviously, in that case, my f of x equation is going to be a lot more complicated, right? So we don't want to have to go through this whole process this many times, right? What I want to do is see if I can find patterns to make my calculations much quicker, right? So Mr. Newton, right, the calculus OG, Mr. Newton, he probably noticed, he's like, hey, if I do value, 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 these values tend to have their own pattern. Well, graphically, what do we call that pattern? We call it an equation. Okay, what's the slope to this? 2. What's its y-intercept? 0. So what that means is that any value of the derivative for this equation can be represented by this equation. Now what I could do in the future to save time is instead of having to go through and do a limit definition here, right? Couldn't I come up with an equation and then just plug the values I need one at a time into the equation? You with me? Okay, so if I'm looking at this here and I rewrite these each like this, the only difference between what I have going on here in the table and this is that instead of my specific A value, I have X, right? So then, who knows if this is how it happened, but in my head, Mr. Newton is under an apple tree, right? He goes, I wonder what would happen if instead of performing this limit definition at a specific A value, what if instead I did it at X? Lily, if you want those to get flatter, do it on the desk, sweetie. And if you stand here, you can get more leverage. So if you stand on the table here and push on it, you can get it flatter like a pancake. Okay, so here, this is not a whiteboard marker. This would be an actual marker. This is very anticlimactic for you guys. I apologize. Here we go, here we go.
Really exciting.
So, I know, right? Me teaching my daughter about leverage. Okay, so the idea is, what if instead of at a specific value, I tried to do my limit definition in general in terms of X? Would it work the same way? Well, we're going to do this first one together so I can show you that it will. So f prime of x, the limit as h goes to 0 of x plus h squared minus x minus h squared all over 2h. Isn't this exactly what you guys did on your paper? You just, instead of x, put in whatever your phone pocket number was, like I asked you to, right?
Yeah.
Okay, so then I come here and I say, okay, well, f prime of x, my limit as h goes to 0, I'm going to go ahead and FOIL this out. Again, super similar to the work you have on your papers, right? So 2h, h squared.
So we're just doing more algebra, but like with easier. 2hx.
Thank you. Well, actually the point is that we're doing less algebra, because if I only have to do this one time per equation, then I could plug in what other point I want, right, for my table into the equation. Instead of every single time having to do it for every point and finding a pattern, let's do it once, right, and find the equation. Now for those of you in physics, I know there's shortcut rules to not have to do the definition. We're going to do those after fall break. Before fall break, we're going to continue this method, okay? But if you do know those, it's not a bad idea to use those to check your work. In fact, I think it's a good idea, okay? So here I have my limit, h goes to 0. Whoa, what? Ignore that.
It's on the h.
Yeah, it's on the H.
Oh, thank you. Okay, x squared minus x squared, so it's 4hx, right, over 2h. So I'm left with f prime of x equals 2x.
Oh, yeah.
So today what we're doing is taking our same process, but we're actually going to learn that there's two more processes. But what we're going to do is we're going to take our limit definitions, and instead of applying them to a specific value, okay, we're going to apply them to a rule here. That's the only difference. Besides, there are two new limit definitions which are supposed to be secret still. Pretend you never saw anything. Nothing. Nothing. You didn't see anything.
I didn't even know.
Well, wonderful. Okay, are we doing okay? Okay, so in math, like I said, we combine the idea of patterns and laziness, right? So when Isaac Newton's going through and doing this, he thought to himself, wait a minute. If the first way I could make my life easier is by generalizing my limit definition to come up with equations, okay? What if there was a way to make the limit defin itself easier, okay? So here's the first thing that we're gonna do. What he realized is that right now our limit definition, just to give you a quick reminder, here's our general limit definition. I'm going to move now to, instead of a, I'm going to generalize it at x, right? So right now we have this x plus h and x minus h, and there's this distance h in between here and here. And we're looking for the representation of that line, right? Thank you. So the first thing Isaac Newton did is he said, wait a minute, I don't need 3 points, okay, over there. I don't need 3 points to find the slope, right? I only need 2. And don't I already have a point right here?
Yes.
Okay, so his first way that he's simplifying is by saying I don't need the x minus h point, I only need the x plus h point. Lily, you gotta move. Oh man, that's a winner. Face just right in front of the screen. I have no intention of editing any of this. Lily, you gotta go, but for real, you gotta go over there and play with Play-Doh or something. Okay? Okay, thank you. This is gonna be a good one. Okay, so
Iconic.
right. So the thought is that the stuff I don't want to erase, I'll just put too high for her to erase. Okay, the thought is, I want you to imagine this. The thought is, I'm not saying, I'm going to try and like pretend like I'm zooming in here, okay? I'm not saying that this one right here, and then, oh, yeah, those could go. Yeah.
Anything within her grasp.
Yeah.
dollar class average.
I know. Okay, I'm not saying that the slope of this secant is a better estimate of the blue than the slope of this secant. I have no idea what she's doing.
She needs to get
She
higher.
needs to get higher so that
Is that
everything
what
can
she's
go.
doing?
Yes.
Okay, she's actually kind of smart. I'm a little proud of her, you know.
She's problem solving.
I don't care as long as she doesn't come over here. Okay, you guys, you gotta try and ignore her today. Lily, use the blue chair. There's less. It'll be harder, easier to get the blue chair.
Yeah, but
You do you, girl. I don't care. Okay, stay with me. This is the whole point. Stay with me, stay with me. Just ignore the little cuteness happening over there. I'm sorry.
It is very.
My daycare canceled at 9 p.m., so it was either me take today off and have you watch this lesson with a video. Yeah.
Yeah, that would.
Didn't
that
think
would
so.
happen.
I mean, no offense to those of you watching the video. Okay. Okay, look. So I'm not saying that this secant, right, and this secant, obviously this secant that's centered around the X is a way better estimate of the blue than this one, right? But what Isaac Newton said is, but we don't really care about the starting secant, right? What we care about is the secant. What? Yeah, you can get rid of all of it, girl. Okay, is that we care about the secant as it gets infinitely small, right? Does that make sense? So the idea is not that me saying that, obviously right now, this is the best estimate. But aren't we taking the limit as h becomes small no matter what? So this one, as it gets infinitely tiny, is as equally good as this one, and this one's going to end up being easier for us.
Oh, because it gets.
Right?
Because it's
Because
less
you see how the
points.
slope levels out. You with me? Because it's less points. Okay? So the 2 points on this one that we'll be finding the slope between are here and here. Yeah, it can all go. That'd be great. Good? We doing okay? Okay, so now let's find the slope between these 2 points like we did before.
The remote. The remote.
If you listen real quiet, sometimes she does both sides of the conversation. That's pretty funny. All right, the limit as h goes to 0, so I'm going to start by finding the slope between those 2 points. Whoa. We doing okay? So remember that this represents the slope of secant, or the ARC, right? But this represents the IRC, or the slope of tangent. And again, I'm not trying to convince you that the slope of those lines as is a better estimate for the slope of the tangent blue, because it's not. I'm saying that it's as equally good when I find its limit. And it's going to be easier once I simplify the bottom, but that's your job. Simplify what you can. What can be simplified there?
The x minus x.
Yeah. The only thing that I can get rid of on the bottom is x minus x. Yeah. So hopefully you can already see why this one's a little easier, because I have less stuff to plug in and FOIL out, right? I don't have to worry about plugging in the x minus h. That is, with the limit, you better put that limit notation there. Thank you.
I have it in the.
Okay, so let's practice one of these. Do you guys want to practice first a conjugate or a common denominator? Conjugate? Okay. So what I want is I want us to fill out this table here. No, we'll just do 4. But I don't want us, but we're not going to go through and find all those A values. We're going to find one equation and just plug those values in. You with me? So I'm not going to do like I had you do at the beginning, right? I'm going to say, let's find the f prime of x equation, right? And then we'll just plug each of these numbers into the equation, okay? So we'll do f of x is the square root of x plus 1, okay?
Hold on. We put,
So let me help you set it up first. So f prime of x is the limit as h goes to 0, x plus h plus 1 minus x plus 1 all over h. Can you do it from there with the conjugate?
Yeah.
Yeah? Okay, take a second and do it from there with the conjugate. Natalie, you okay? You guys okay?
Oh, that's what I was doing.
Natalie, it's yeah, right?
Add a plus and a minus. You change the sign. So instead of being minus, you choose the addition. It's not 1.
I don't know.
Well, I'm not even done. You have to wait.
Yeah. No, you already got those?
I got the equation.
Oh, yeah, no, I'll take volunteers on the next one. On this first one, I think I'm just gonna work it out. Yeah.
I don't need to, I got a number.
Yes.
But it works out now.
Did you plug some of these in for x?
Did you multiply the conjugate on the bottom too?
Oh yeah, you gotta remember to multiply the conjugate
That's
on the
what I
bottom.
did, and then I was like, hold on.
Silly.
I forgot my limit notation. I'm so embarrassed.
Oh, well, nobody would have known until you announced it.
What did you get? Yeah, I was like, yours looks way better. Can you go further? Because then now you have rotations and no, because the age cancel the age. Yeah, so now there's no one this night. You're right. So yeah.
So I got 1 over 2 square root x plus 1.
Oh, there's 2.
Right? Then, if I want to then find these things, notice, instead of having to go through that a bunch of times, I can now just take plug in 1. 1 over 2 square root 2, right? 1 plus 1. Now I'm just taking my numbers and I'm just plugging them into my equation.
Just to clarify, so when you plug in so we're finding the prime, f prime of x.
We're finding the whole equation.
As limit x equals to 0, right? So you plug in where f of x, the equation, into where x is on the equation.
Yep.
X plus h plus 1. So it's going to be x plus 1 plus 1.
Yeah, whatever.
But it's not x plus 1.
As long as the plus h is in the square root. How you guys doing? You ready to try one on your own? Are you guys doing okay? Everybody good? Any questions?
This is how she is. I feel like that.
I actually don't.
There might be.
Okay.
Yeah, it'll be just a normal days of homework though. Yeah, well, I'm not giving like extra homework over fall break. You already have extra homework because you have to study 30 minutes a day.
Yeah.
If you go 5 days without doing any calculus, you guys will reap the benefits of that, I promise. I mean, you can make your own decision, just know when you come back the next week, you're gonna be not happy. Huh? Yeah, I go all summer without calculus. But, okay. You guys wanna try one with the new method? Okay, I'm gonna have you try one with the new method and then we'll get out our blue topics lists and add some things to them. Baby blue. Okay, so try this one now. I want you to fill in this table, but I only want you to do the limit definition one time. Obviously these are just random numbers, right? You guys get with the table, I'm trying to make a point, right? Instead of having to go through and do the limit definition for each data point, we're just doing it once to find the whole pattern equation and then plugging the points in. You guys with me?
Yeah.
Okay, so for this one, let's do f of x equals, ooh, you ready for a tricky one? I know it.
Ew.
Ew. I didn't say it was hard, I said it was tricky. Okay, so I want you to find for me, it's f prime of x equation. I'm just gonna do the first step for you up here, just because I feel like it.
So like if we like watch videos like every day, that like
Oh, wrong.
Yeah. I got too lazy to do unit circle quizzes towards the end because like your grades were done and I was like so happy, so I didn't give quizzes in a while. But chances are you might want to refresh on that for the beginning of next term. Hint, hint, wink, wink.
A unit circle?
Maybe. I also think we're ready to start some maybe quadratic factoring bell quizzes.
What?
There's lots of stuff you can do over the fall break to not lose your math skills.
I know what
this
that's
is
like.
this is something you can do so you're not.
There's already so much stuff there. Have you done any of the optional factoring or unit circle stuff already there?
Yeah.
Well, do it again. Do you remember it all? Probably not. You are so cute. Be my babysitter, Natalie. Holy cow. You are a babysitter? Oh, how funny. To make money, Lily. She's gotta make money. You don't have to play with her, but if you need the brain break, you're more than welcome to. Yeah, I get it. Oh, yeah. Is it on the use substitution? Natalie's nice, huh, Lily? Natalie's one of my favorite students. Did you do that use substitution one okay?
Oh.
So
Tell me
close.
now.
Wait,
When you go from here to here, you have to square root 5, 5, 2, 2. Like you have to square root
That's why it's
to split it. Does that make sense? So
Yeah.
this should be, instead of 25, 25, it should be 5, 5, and 2, and 2. Then it's perfect.
This is not right. And
So you go here, and then what numbers have you tried? Oh, have you tried 5 or negative 5?
x plus h squared.
Like when you plug them in here to see if they work? No, she doesn't need to erase yet, Lily. Oh, you tried those 3, they didn't work. You have to do plus and minus. I bet negative 5 works.
I don't think I'm
Is that
doing
who's
right.
on it?
I just want to see what your steps confuse you. No, because I don't have steps, Jason. Oh.
So any of them would work at any time. Like you can do any of them for any of them.
Yeah.
So usually if
But when you're done, I could
when you're doing your homework, if I let you choose which one to do, then I almost would never do this one because it's harder. I would always do this one because it's easier, right? But sometimes I ask you to do like a specific one, but that's just so it's easier for me to check answers, like when I check work or something, or to like test if you know it. So usually if you have the choice, I almost always do this one. And if you don't have the choice, you don't have to do that first one if they ask you to, because it's like they're testing you on that first
Maybe
one.
this is
Does
too
that make,
tricky.
does that make sense? The only time you have to do the more complicated one is if they specifically
Do you ever
ask
get
you the
extra
question
cards?
to do it.
Yes. Okay. I'm like,
So they have different names.
Right.
They'll say using rule 1, rule 2, or rule 3. Okay, does that help?
Because don't you guys like put a zero on top?
Do you guys want me to start working it out?
that'd be
Yes,
great.
please.
Okay.
Wait, I know what I did wrong.
Oh.
So far, so good. No, so far I'm doing it right.
That's making it so complicated. She doing art too?
So I like to be like, you don't have to do this in like the first step. I like to because my math teacher heart can't handle like fractions over fractions over fractions, right? So I always like to bring this up in like the first step and just kind of tack it on the end there and deal with it later. Just because I like the way it looks better, but you can do the all over H as long as you want. I just can't handle it. So, because my math teacher heart is, I can't deal. Are we doing okay? So far okay?
I just have a question.
Why is this the cutest thing you've ever seen in your entire life?
That is pretty cute.
I know. Sorry, go ahead.
No. it's like-
Facebook. Yeah.
I have this.
Yeah.
There.
Yeah.
Do the x squareds just once?
Yeah, but you still have to give the negative to everything.
Right. So
Yeah.
then I just have the negative side.
But it's okay, the x squared is the only thing we need to cancel because everything else has an h in it, which tells me I can factor out an h in a couple steps. Okay, I'm gonna keep going. F prime of x is the limit, h goes to 0. Got x squared minus x squared plus 2xh plus h squared. Some people take the time to like foil out the bottom or whatever, but we're about to put in h is 0, we hope, eventually anyway, right? So I wouldn't even worry about that. I think it's just a step. I mean, you can. I just think it's a step that doesn't matter if you do it, and then it's just another chance to mess up on your algebra. Does that make sense? Okay. Then I have f prime of x, limit, h goes to 0. So these subtract, right? And then I distribute my negative. So negative 2xh minus h squared, x plus h squared. Okay, now I'm going to perform some math magic. Are you ready?
I'm so ready.
You ready? I'm going to get rid of an h by factoring an h out.
Can it be a negative H? So that's
You can, but I just don't want to because I want to be able to just cross it off really easy. I like things to reduce to 1 instead of negative 1 because I'm a hater, but minus h x squared, because you can only reduce a fraction over multiplication, right? So, gone. And look, that was my divide by 0 error. You with me? So now I'm ready to make my h become 0. Over what? X to the 4th. So f prime of x is negative 2 over x cubed. So negative 2 over 1 cubed, negative 2 over 2 cubed, thank you. My brain is melting. -3, no, the 2 doesn't change. -2 over 3 cubed, -2 27ths, -2 over 4 cubed.
That's -1/3.
Great.
Okay.
I know my multiple before because of Minecraft, guys.
When I assign your homework tonight, like, I'm expecting, like, if you're taking much more than like 10 or 15 minutes per question, then you probably should stop and rewatch the videos or come in, you know, tomorrow or Wednesday and get help from me or something, right? But if you're going, like, if you're checking your work and going really slow, then I would think 10 or 15 minutes max is about where you get, hopefully where you'd be. If you're doing much more than that, then you need to rewatch the videos or try something else, okay?
Don't die.
Okay.
I really understand that question.
I don't know. I think no matter what if you're too fast, like if you're taking a couple minutes to do these problems, then you probably forgot your limit notation. Do you know what I mean? Or a negative somewhere. Like if you're really going and being thorough and double checking your limit notations, I would say about 4 or 5 minutes. Yeah. But I'm happy if you're getting them right with limit notation at 10 or 15 minutes at this point, right?
So on the homework, are we just finding the derivative equation, or are we also doing points now?
You're only doing the derivative equation. Okay? Okay, get out your baby blues, and then we'll do our last limit definition here in a second. But there's actually a third one that's a little different than the first two, but we'll talk about it in a second. If, as you go through these, the one that they test on, like 80% of the time, is the last one. Or sorry, not the last one, the second one. The one that I have starred here. This is the one that they test on like 80% of the time.
Okay, so you're saying.
So if you can do all three, great. If you're only gonna pick one to work on and then hope the others don't show up, then only worry about the second one, okay? But there's 3 of them, and I haven't put the third one up there yet because I want to talk about it separate. Huh?
It's a shortcut.
The shortcut rules they're a whole unit.
Yeah. So you just want to start right now?
Wait, what
What
are we
class period is it?
7.
So we have a half an hour, not 3 minutes, right?
Yeah.
Oh, this is weird.
Wait, where's the rollers at?
They're in the cabinet over there. What do you need a ruler for?
To make it straight.
You gotta make that divide sign perfect.
Are you kidding me? I almost want to refuse to let you to do that. You gotta get over that for sectionism level.
Oh, you should see my math before I do. I don't use nothing except for stuff I actually see.
Oh my gosh. You want one bad enough, you can find it yourself. I did it. No, you're not done at all. Okay.
You should see my garage. It's not crapping around.
Okay, so there's 3 limit definitions of a derivative. So 1, 2, and then the third one we'll do in a second, but that's what you should be writing down. Don't write what's under those graph magnets. That's part of your homework tonight. So any questions? No, this looks perfect. Wait, it should have been. What's happening here? But it's just the wrong sign. But it should have worked, I thought. But so I wonder if you missed a negative somewhere. -15. -7. That's -2. So you added these to +2 instead of -2. Okay, so 5 minus 3 is 2. I want -2. So -7. Uh-huh. You have to fix the rest of them. Are you coloring a rainbow in the lines? Love that rainbow. That makes a nice little kid. That one I'm pretty sure should work. Yeah, that one should work, right? Remember, if this is the one that works, you do
Yeah, that's my favorite. is the
-5. Make it, that's why, that's why.
I'm not here to interrupt, so we just have a brief moment.
Brief moment. I'm recording. Can I give you guys one to try really quick?
Yeah.
Okay, let me stop the